Okay, fellas, so we're back in business. I got this pump put back together. Unfortunately, the seals don't fit this different pump quite as well as I did the other one. And I'm gonna have to put some gasket compound in there to seal this thing off permanently. It still leaks, but we're gonna run the test anyway. I don't wanna mess with this pump anymore. Here is the new safety rig. We have a 150 PSI pressure relief valve connected to a pressure gauge, and we even got our air cavity here per Adrian's suggestion, kind of knock some of them pressure spikes out of the system. So we're going to see how this thing works. It's definitely going to leak like a sieve right now, but after this test I am going to take the pump back apart, dry it out, and then put some sealer on it. I didn't think it would need a sealer. It looked like just rubber gaskets, so nonetheless, I don't know if these ones, you know, now that I think about it, these ones do look a little bigger. So that's what's happening. This little rim here, it's not fitting into the gasket seat very well. I may have also deformed it, removing it. If you stretch this material, it does not have a very good elasticity. It will not return back to its original shape, and that's probably what I did. So, let's check it out. But anyway, this is what we got. We got a minor drip there. The seal is leaking. I have the heating system on. We're currently putting water out at 133 degrees there, apparently. Oh yeah, that's nice and warm. So, let's fire the pump up, see what happens. Oh man. Nice. We're getting some good pressure though. We're doing it. Ridiculous. $36.6 pounds. Kicked off the pressure relief valve. I'm gonna open that valve back up. We'll get electrocuted before the day's out. basically what happened that time is the thermocouple popped out on me. And that's in there tight too. Probably should have oiled that. So I'm gonna strap that in. I think I'm gonna go ahead and call it a day on the testing with this part of it. I'm gonna take this pump back off of here and go ahead and put some sealing compound on the new setup there. Everything else seemed to work okay other than this thing, but for the most part we'll probably end up just hooking up this other pump that I have. It's only rated for 120 psi's though. And we are running at about 140 on that one. So nonetheless, I am glad to see that we were getting a high temperature flame all the way to the end of the burner. I've never seen that thing glowing like that, so that was cool for sure. Well, I have, but not as well. It seems like in the past they never did as good. So this bigger boiler's paying off, I think. This one's got a lot more preheat coils, which I will admit I don't know if I like that. I'm almost thinking I need to limit the preheat coils to the 6 wraps like before and leave this end shrouded out, because it's very important that that combustion chamber get red hot for optimum performance, and it's not now. And I can tell this torch does not light the way the other one did. It doesn't behave the way the other one did. There's some minor subtle changes, and they're very apparent in the operation of the burner. So let me get this thing sealed up, guys, and we'll try it again. The rig ended up just turning into an elaborate monster here. It's going to be like $45 in parts to protect a $30 pump. So, pretty interesting. I got to do it right. So, hopefully this time we don't get any pump failures. This particular setup here has a pressure relief valve set at 150 psi's. It's also going to have an air cavity that's going to absorb any pressure spikes that may rupture the diaphragm in their absence. So hopefully that'll work out. We're also going to have a pressure gauge on here just to kind of get an idea of what's going on. That's probably going to end up having to be on everything. Not having a pressure gauge is a bad deal, but I was hoping to get away with it, and I did not. Usually when I solder this stuff, I have a sequence I like to do. Dropping it is certainly not a part of that sequence. Seems like it held out okay. Man, what the hell's going on there? I like to do the gravity deal, where I'm using gravity to give me a decent joint. I'll never do my bottoms as I'm doing the tops. The solder just runs all over the place. This is a acetone infused oxyhydrogen flame that I'm using. It's an oxyhydrogen torch. And this particular gas formula makes an amazing soldering and brazing gas. First of all, acetone gas in itself reacts with hot copper, causing an exothermic reaction to release heat. So any of the acetone that isn't being burned at the interface layer of the work is being used to actually undergo a catalytic reaction. Pretty cool stuff. Okay, I think this side now. So that's one of the reasons it makes such a superb soldering gas. Definitely a very forgiving gas as well. It's not the type of flame that you can easily scorch an area that will no longer receive your brazing or soldering alloy, which is great. Okay, this one here, I think I'm just going to go ahead and do a side joint. These here seem to flow okay. It's just too much spinning on this one. Kind of hard to do, but you don't want to get it too hot. That's another thing I like about this torch is you can really control the heat with this thing. You can get it right on the verge of melting the solder without overdoing it, which is pretty nice. Yeah, I definitely overheated that area by quite a bit. Not too worried about it though. We're going to stop that there and connect it up to the unit. For any of you who haven't seen this thing yet, this monstrosity, this is what I'm using to produce that gas. This is a very powerful electrolysis cell. I then pump that gas through the acetone infuser. And even though there wasn't any copper on this particular run, it's still a very compatible gas with brasses. But when you're heating copper, man, is it amazing. You ought to check it out sometimes. If you look up acetone copper reaction, you'll know what I'm talking about. It'll give you a whole new perspective on what I'm doing here. A lot of people may not get why I do this, but you know what? Go ahead and leave this video right now and look that up and check it out. Acetone copper reaction. Definitely pretty cool.